Welcome back, my fellow causal champions. My name is Dan Harris, and I'm your host today on Causal Discoveries. This episode continues the series investigating the theory of universal specificity, which directly challenges the venerated theory of relativity. Be sure to subscribe below to keep informed as to when new episodes in this series are released. Earlier in this series, I made the bold claim, by way of an analogy, that relativity is to the geocentric planetary model, as universal specificity is to the heliocentric planetary model. I then outlined 5 parallels between Kepler's work on validating the heliocentric over the geocentric model and my work on validating universal specificity over relativity, which will be covered in this series. Most recently, we covered the first 2 parallels in more depth, at least the second one partially, and check out these earlier episodes linked below for the full discussion. In this episode, we have a returning guest lineup to help us cover the third parallel, the anomaly that results from studying special relativity, which can only be resolved if relativity's contrary assumption, and therefore its competing model, is true. I hope you enjoy this episode on Causal Discoveries. Today, we'll start by discussing how an anomaly came along with the publication of special relativity papers in 1905. This anomaly goes by the name relativity of simultaneity, where the simultaneity of distant events is no longer absolute according to the theory of special relativity. To help us better understand this, please welcome back our last episode's guest, Albert Einstein. Thank you. To begin, Albert, how does special theory of relativity lead to the relativity of simultaneity?
That is the right question to ask, my friend. To illustrate, I like to use this thought experiment involving a train moving on rails. Now the lightning strikes each end of the train, and the light from both arrives at the center at the same time. This simultaneous arrival of the photons is never in dispute because there's no distance between them. They arrive at the same point at the same time. Only events with distance between them can be in dispute in terms of the simultaneity according to relativity. The events in dispute in this case are the lightning strikes. Does it strike the front first, the rear first, or at the same time? Now, if your reference frame is such that you're at the center of the train, so you're moving with the train is essentially not moving relative to you. So in this case, the velocity is 0. Okay, so the distance covered is the same at either end. You have the distance to the rear, your distance in the front, and they are equal distant. Now, because of the light postulate, where the speed of light travels at the same rate in all directions, and it's over the same distance, they arrive at the same time, you can deduce they must have left at the same time to cover the same distance to arrive at the same time. See? So, for this perspective, the lightning strikes are simultaneous. But what happens when the perspective changes from being on the train and where the train appears to be stationary to being on the platform where the train appears to be moving? In this case, the boxcar is not stationary through time. It appears to move, let's say, to the right. See? Like this as a function of time. So this will be like T0, T1, and T2. Okay, so I say the lightning strikes here first, followed by, and T1 strikes here, so that when they arrive at the center, the photons from the lightning strikes arrive at the same point. So the center is moving as well. And the photon from the first strike is roughly here on T1. Now, if you were to look at all the distance traveled from each of the strikes to the center, you'll notice some differences here between this case and the previous case. The distances were equal here. They are not equal here. You've got this distance here, where the real lightning photon had to travel from this moment of the strike to the center. And then you have this distance here, which is where it strikes from the front to the center. Because the train is moving after each of the strikes, for the rear, the center is getting further and further away according to, say, it's this, in this case, the velocity vector to the right. And then as this lightning strikes, the center is moving closer towards it. So this distance from the front and distance to the rear is such that the distance to the rear is greater than the distance to the front. And because of the light postulate, where the speed of light is the same for all observers, including the gentleman or the lady on the platform, and you see the longer distance here and the shorter distance here, that means the light must have left first to make up the difference for this long distance. And then it left second. So the simultaneity of each of these events is in dispute. Which struck first? According to the guy on the platform, it was the rear that struck first, and according to the person on the train, they struck at the same time.
What happens from the perspective of a faster moving train that moves faster than the one that got struck by lightning?
It's the same exact situation as you have on the platform's perspective, but in reverse. The train that has the lightning strike both ends appears to be moving in the opposite direction because the faster train is overtaking it. Its velocity vector is even greater. And because of this, the rear photon no longer strikes first. It has no longer more distance to cover. It's the front photon that has more distance to cover. So according to the moving faster train, that one strikes first. The front of the train strikes first, followed by the rear. Now, these three situations, the lightning strikes the rear first, the front first, and simultaneously, are the three basic results of any distant events that can be said to occur simultaneously.
Okay, which conclusion is correct then?
Well, they are all correct. According to special relativity, the order of events is no longer absolute. It depends on the inertial reference frame.
I can understand a model leading to contradictory conclusions if used in different contexts, but only one outcome can truly correspond to reality, right?
If only one were true, then relativity would be wrong.
What do you mean?
I mean, if only one were true, then the speed of light would not be constant for all observers. If so, the assumption at the base of relativity, the light postulate, would be false, making the theory false.
Isn't one event being before, during, and after another event a contradiction?
How so?
Well, isn't a contradiction something that is and isn't at the same time in the same respect?
Yes, but how is that at the same time?
Well, at the rear of the train, and in the moment the lightning strikes, isn't the following true about the lightning strike at the front of the train? It simultaneously would have struck in the past, is striking now, and will be striking in the future.
I see. Yes, but how is it at the same respect?
Well, in this case, the respect is when lightning strikes the front of the train. And theory claims, special relativity theory claims, that it strikes in the past, present, and future.
I see. Then yes, the moment the lightning strikes the rear, the predictions that lightning strikes the front in the past, present, and future is a contradiction.
How does relativity resolve this contradiction?
It doesn't. This contradiction results from assuming that the speed of light is constant in all inertial frames. So the only way to resolve this contradiction is to reject that assumption as false. It means out of the many predictions of the sequence of lightning strikes, only one can correspond to reality. This means that light is constant in all directions in the inertial frames that makes this true prediction.
So this means the contrary assumption at the base of Lorentz ether theory, which was discussed last episode, is correct, right?
Yes, it appears so.
Wow. Thanks, Albert, for joining us again on Causal Discoveries. Albert Einstein, everyone.
Thank you.
You know, I have a feeling we'll be seeing him again very soon when we discuss gravity. But wow, that conversation took a crazy turn of events. You know, I often wondered why an assumption is accepted for so long without detecting that it results in a contradiction when it's basically staring us right in the face? I don't have a good answer for this, but I've speculated that perhaps since relativity makes such accurate predictions, people concluded that this somehow means it must be right. And they lack the historical context surrounding the debate between the geocentric and heliocentric planetary models. History shows us that accurate predictions does not necessarily imply that a theory is correct. Or perhaps a lack of evidence for one idea was taken as evidence for a different idea. That being, the ether couldn't be detected, and distant events could not therefore be related simultaneously, and therefore perhaps the idea that simultaneous distance events seemed unreal because it could not be measured. And because it seemed unreal, it may have escaped the thinking that concluding it is unreal leads to a contradiction. And lastly, I wondered if a counterintuitive idea that is also correct somehow becomes more sensational and appears more profound in people's minds. And if that's the case, that gave special relativity an edge over the Lorentz ether theory, because nothing can be quite as counterintuitive as adopting a contradiction as true and trying to make it work. Whatever the reason, though, given what we know now, it's impossible to ignore that special relativity leads to a contradiction that can only be resolved if its contrary assumption at the base of the Lorentz ether theory is true. And so that completes the objective for this episode, which was to partially cover the third parallel between Kepler's work on planetary motion and my work on universal specificity. And until we discuss gravity, parallels 2 and 3 will remain partially completed. Up next, however, a new host will lead you on causal discoveries. Aww. I know, it's sad, but don't despair. You haven't gotten rid of me just yet. I'll be returning as a guest to help the host cover one of the many causal discoveries I made, the cause of time dilation. I thought that might cheer you up. And until then, you can review the status of this series production by referencing the WordPress link below, which captures the draft outline of this video series and the progress of its development. And don't forget to like, subscribe, and share if you've enjoyed this episode. And please add your comments and questions below. We want to hear from you. Again, I'm Dan Harris, and until next time, enjoy making causal discoveries.
Let's go. Yeah. I'm like an addict, do I gotta have it. I ain't even playing, got a really bad habit. If it moves, gotta grab it, fuse like a magnet. Lose, won't have it till I'm doomed in a casket. I ain't playing, got a weird mind. If you work 8 hours, I'ma work 9. If the shoot tastes sour, you should taste mine. I'ma stay in power for a long time. Get up, nah, I ain't a quitter. Toss me the ball, I'm a really big hitter. Big picture, I'm a straight killer. Rising the song to the highest bidder. Got juice, got gas, I'ma move fast. New shoes, new tracks, like who's that? I'm new, come back, better than last. Yeah, it's a new me, never gonna look back. I'm never gonna look back. Cause damn, I was built to last. You move slow and I move fast, and that's facts. Only I can make a change. Slowly